Hi, in this video, I will be showing you problem number 9 from the practice exam 1, which covers chapter 1, 2 and 3. Solve the compound inequality. 4x minus 5 greater than or equal to negative 25 and 2x minus 4 less than negative 6. Graph the solution on the number line. So it is a compound inequality. And there are two inequalities given, and it is compounded by the compound statement and. So let me show this first for the problem given, where the two inequalities are combined by the and statement. Then next I'll also show as an example what the variation could be if the same two inequalities are connected by or, how you can graph the line. So let's first take these two inequalities and solve. 4x minus 5 greater than or equal to negative 25. And we'll keep the and as is. 2x minus 4 strictly less than negative 6. First we have to isolate the x. So we'll add 5 to both sides. So we get 4x greater than or equal to negative 20. So divide both sides by 4. That will give us x more than or equal to negative 5. So that is one solution. Then we will keep the and as given in the problem. Then we will solve for x from this inequality, 2x minus 4 less than negative 6. So we have to isolate the x here. So add 4 to both sides. So you get 2x less than negative 2. Divide both sides by 2. So you get x less than negative 1. We'll see how these can be graphed. So the question is to graph. So let's have the number line. Then we'll consider this negative 1 and negative 5 on the number line in that order. So this will be negative 5. And this will be, say, negative 1, roughly, not scaling it, negative 1. Let's circle this one, and there is a solid dot here. The reason is, for greater than or equal to is equal to sign is included for negative 5, so that will be a solid dot. Here you don't see the equal to sign for less than negative 1, so we have a hole for negative 1. Then we'll interpret this, x is more than or equal to negative 5. So I'm going to shade that part just to the right of negative 5, including negative 5. So it is this part which is shaded. So it is all to the right of negative 5. Then let me use another color. X is strictly less than negative 1. So it is all to the left of negative 1. So it is this part. X less than negative 1 and x more than or equal to negative 5. So because the question is and means actually what is common. So we have to see what is the overlapping area, or which is the one which is shaded in both colors. So which part of this number line is shaded in both colors. You notice here that one is shaded red, the other one is shaded green. So we have to look for the one area which is shaded in both colors, which is negative 5 through negative 1. So the solution here is actually in the number line, it is only negative 5 to negative 1. So if you do the number line again, so place negative 5 with a solid dot, place negative 1 as a whole, then you have to actually shade this part which is negative 5 through negative 1. Solution in graph. As a remark, I can say, if the question was asked that the solution be presented in the interval notation, the interval form of the same graphical solution that you got before, which is negative 5 through negative 1. Note that negative 5 is solid, negative 1 is a whole for the reason that we mentioned earlier. So in the interval form, you have to include negative 5 and exclude negative 1. So negative 5 is closed to bracket, negative 1 is open. Now I am going to show you the variation to this problem, number 9. Solve the compound inequality 4x minus 5 more than or equal to negative 25 or 2x minus 4 less than negative 6. Graph the solution set on the numbered line. So instead of the word and, the two inequalities are connected by the word or. So in which case, what modification would you do on the numbered line? So first let's solve as we did each inequality. So 4x minus 5 is more than or equal to negative 25. So if you add 5 to both sides, we get 4x is more than or equal to negative 20. Then you divide both sides by 4. So you get x more than or equal to negative 5. That is one solution. And here it is connected by r, so we'll keep that r as is. Write down the next equation, 2x minus 4 less than negative 6. So add 4 to both sides. So you get 2x less than negative 2. Divide both sides by 2. So you get x strictly less than negative 1. So this is another inequality. And we have to connect them by r. So as we did earlier, we have to draw the number line. Mark these 2 points. One is negative 5, which is solid because it includes the equal to sign above. Then the other one is negative 1, which doesn't have the equal to sign. So we have to just make it a whole for negative 1. X is more than or equal to negative 5. I'm going to shade it in red. X is more than or equal to negative 5, all to the right of negative 5. Then the other one is x strictly less than negative 1, so all to the left of negative 1. I'm going to shade that in green. The red one is x more than or equal to negative 5. Now because it is connected by r, what is it? The leftmost is negative infinity, rightmost is positive infinity. When the question is or, we have to consider the totality of all elements present in this set and that set, which is x more than or equal to negative 5, x less than negative 1, all the elements belonging to these two inequalities or these two sets. So that actually starts at negative infinity and ends at positive infinity. Pretty much we are considering the whole entire shaded region on the number line. The entire shaded region is negative infinity through positive infinity. So you can write that, you can just shade the entire number line, which is negative infinity here, positive infinity, and say that the entire real line is a solution to this problem in terms of graph. The graphical method, the solution is negative infinity to positive infinity. If the question was asking you to write the solution in the interval form for the same problem, it would be the lowest number to the highest number, which is a shaded one. So both infinity or negative infinity can never be a bracket. So it is open negative infinity to open infinity. So all numbers lying between negative infinity to positive infinity. So in this problem, they ask you only the graphical solution. You don't have to write negative infinity to positive infinity in the interval form. But in case they ask you in interval form, this would be your answer. Same way for the previous problem, the question is asking us to do only the graph. So you have to leave it that way. Negative 5 to negative 1. Shade. Negative 5 is inclusive, solid dot. Negative 1 is open dot. Shade the region between negative 5 and negative 1. If the question was interval form, then the answer would have been negative 5 through negative 1, Negative 5 closed bracket, negative 1 open, because one is solid, the other one is open, whole. Hope this video helps.